systems of equations, and we talked about the process called elimination. We're going to keep working on elimination today, but today we're going to add to it a little bit. It's going to be a little bit more challenging than what we had yesterday. Thank you. And the reason is because if we look at these examples that we have, a lot of them have our X's and Y's lined up and our regular numbers lined up, which is what we want. But none of these problems we're able to use elimination right away with. Does anybody see why? We can't actually eliminate on any of these problems yet. See if you can figure out why. Yeah. Exactly. None of the numbers with the variables, none of the coefficients are the same. Yesterday, we saw numbers in front of the variables that were the same, right? Like on our first, well, every example really. So like this one here, number 3 from yesterday's notes, we had 3x and 3x. And because those numbers were the same, we were able to eliminate the x values by subtracting those two equations. There were some examples where we had opposite values as well, a positive and a negative. And with those ones, we added them together. But either way, we always had numbers in front of variables that were either exactly the same or a positive and negative of the same number. We don't have that. And so what we need to do is make adjustments to either one equation or both equations in order to get the same number in front of the variables, to get common coefficients. So we're going to add a little bit to what we learned yesterday. All those things that we learned yesterday still apply, but we're going to add one thing to it, and that is right here. So what if there are no common coefficients? What if the numbers in front of the variables aren't the same at all? We are going to multiply one or both equations by a number to create matching or opposite. This is what we saw yesterday. Either the same or opposite values, coefficients. So we're adding one step to what we saw yesterday. And that step is to multiply either one equation or potentially both equations, if necessary, in order to create matching numbers in front of one of the variables or opposite numbers in front of one of the variables. And so today we're going to need to have a pretty solid understanding of common factors. And I don't know if I have any more. I had some multiplication charts printed out a while ago. I might want to do that again, just because figuring out common factors. If you know your multiplication tables, this is going to be a pretty quick process. But if you have kind of had struggles with that in the past, it could be a bit of a challenge to figure those out. So I might take some time and get those printed off for you, just so we can make this process a little bit quicker. But in the meantime, we'll just go ahead and work through this. So a lot of these are going to be pretty straightforward. Some of them will be a little bit more challenging than others. So if we're looking here at problem number 1, let's just jump in. Example number 1 says x plus 3y equals 6, and we have 2x minus 7y equals negative 1. Now, in terms of elimination, how these are written and how they're stacked up, it's great. X's are with X's, Y's are with Y's, numbers are with numbers. The notes that we wrote down yesterday said step 1, make sure that the equations are lined up. And these are lined up because of what we just talked about. Our next step, though, isn't to add or subtract these two together because we can't eliminate anything yet. So if we look here, can we multiply the top equation or the bottom equation in order to get the same number or opposite numbers in front of either X or Y? Anybody see an availability for that? Sophia, I see you nodding your head, yeah? And what I mean by that is, I'll just go ahead and tell you here. There's a x here and there's a 2x down here. And so the easiest way to make this work on this problem is to multiply the top equation by 2. If we multiply everything in the top equation by 2, that will give us a 2 in front of the x on the top, and it'll match up with the 2 on the x on the bottom. So on this problem, the easiest way for this to happen, there are other ways that we could do this, but the simplest way for this to happen is to multiply the top equation by 2 so we can have a 2 in front of both x's. We don't have to do anything to the second equation because it already has that 2. So if we multiply the entire equation by 2, that means everything on that top equation gets multiplied by 2, not just the value of x. And that's important because if we only change the value of x, we're changing the entire equation. But if we multiply everything by 2, that equation essentially stays the same. We're just increasing it every number by a factor of 2. So we'll do a little, it's like an equal sign, but it turns into an arrow. So you do a little equal sign with an arrowhead at the end of it, just to say, hey, we're going over here. We're going to write some new equations. And when we do that, the only equation that changes is the top one. We multiply everything on the top equation by 2. So that's going to be 2 times x, which is 2x. 2 times 3y is going to be 6y. And 2 times 6 is 12. So we get 2x plus 6y equals 12 for the top equation. And then the bottom equation stays exactly the same because we just wanted to get the numbers with x the same. Now, it wasn't necessarily we wanted the numbers with x the same. It was more about the fact that it was the easiest thing to do was to get the numbers with x being the same. So that second equation doesn't change. All right. Now, if we look at it, we've got everything lined up and we have the same number with one of our variables. So that means we can then add or subtract the 2 equations in order to eliminate one of the variables. So if you were gone yesterday, this is what we were doing yesterday. We started off with problems that looked like this. And then we had to either add or subtract the equations together to eliminate one of our variables. So on this problem here, we've got a 2x and a 2x. So if we wanted to make these 2x's equal to 0, would we have to add them together or subtract them? Yeah, we're going to subtract them. Anytime the numbers are exactly the same, you will subtract your 2 equations. Because 2x minus 2x is 0. That's what we're going for. We want to eliminate the x terms here. And then when we do that, that just gives us the y variable and then the regular number on the other side. So we have 6y, we're still subtracting, minus -7. It's not 6 minus 7, it's 6 minus -7. And again, if you need a calculator to help you out with the subtracting negative portion of these calculations, please use a calculator. So 6 minus -7 is the same as 6 plus 7, which is 13. So that gives us 13y. And that equals 12 minus -1, which is the same as 12 plus 1, which is 13. So we've eliminated the x's. Yeah, go for it. So we've eliminated the x variables. And we're solving for y now. We've got 13y equals 13. And then to solve for y, divide both sides by 13. And y equals 1. So we have our y variable. And just like with substitution, once you have your first variable, plug your value back into one of the 2 original equations and then solve for the other. So kind of like we did yesterday, do we want to plug it into the first or the second? It doesn't matter. So just show me a 1 or a 2 for first or second equation to plug into. First one, okay. So we're going to plug into x plus 3y equals 6. Now I'm not going to end up rewriting this whole thing like we did with substitution. I'm just going to write x plus 3 and then y is 1. So 3 times y would be 3 times 1 equals 6. So we'll just use that very first original equation and we'll solve for x that way. Do the multiplication real quick. 3 times 1 is 3. So that's x plus 3 equals 6. And then to get x by itself, we'll subtract 3 from both sides, minus 3, and x equals 3. So we've got y equals 1. We've got x equals 3. And then we write our answer because it's a point on the graph, but we always start with x and then y. So 3, 1 inside parentheses. And that is our answer for the first problem there. So the only difference between what we saw yesterday and what we're doing today is that we have to come up with something to multiply either one equation or both equations in order to get the same number in front of x or in front of y. So we're going to do the next, we'll do the next 2, and then we'll probably skip, just want to double check here. Yeah, we'll go ahead and skip 4 and 5, but we'll answer 2 and 3. So go ahead and cross off 4, go ahead and cross off 5, and we'll definitely do 2 and 3. All right. And if there's any questions before we move on, please let me know. All right. So we'll go ahead and take a look at the second problem here. Just a second. All right. Okay. So problem number 2. Which variable do you think would be easiest to match using multiplication on this one, x or y? I agree. It is the y variable. And Kai, why do you say that? Why do you say the y is easier? Yep. We've got a lonely y here, which means if you have a variable by itself in one of your 2 equations, and you don't have any numbers that are matching yet, choose the equation that has the variable by itself and then multiply by whatever you need to match the other variable that has a number with it. That's going to be the simplest way to make that happen. On this first one, we multiply the first equation by 2, because right now that x is a 1, and if you multiply it by 2, you get 2. On this second one, we got a 1 with the y, which means if we multiply it by 3, we're going to get 3. We'll match it there. And that's going to work with any equation where you have a variable by itself. You can multiply by the number in front of the other matching variable to get the same number. So with problem number 2, we're going to get the y variables with the same number in front of them, the same coefficient. So which equation are we going to multiply? And what are we going to multiply it by? Are we going to multiply the first equation or the second equation? On problem number 2. The second equation, good. And what are we going to multiply the second equation by? I would agree with 3, because we want to get the same number in front of the y's. And so if this y equals 1 and that y equals 3, we have to multiply the second equation by 3 to get those numbers the same. So that second equation, everything on that one will multiply by 3. The first equation is not going to change. So when we rewrite our 2 equations, the first equation stays exactly the same, but everything on the second one multiplies by 3. Yes. Yeah. Yeah. Mm-hmm. Absolutely, we can. Yes. Yep. We can. And I'll show that on the next one, because we won't have to multiply by a negative on this one to do that. But yes, that will also work. If you'd rather just always add the equations together instead of deciding if you have to add or subtract, if you're looking to just be able to add them together, you can always make sure that the variable that you're trying to get the same is the opposite variable. That is something that we can do if that's something that you prefer. So what Miss Eddie was saying is, if we multiply everything by -3, then the 3 and the -3 would add together to cancel out. And that is something you are absolutely able to do if you would prefer to add. It will end up doing the same thing either way. So yeah, let's go ahead and do that. Let's multiply by -3 instead, just to show you that it doesn't make a difference in terms of what the final answer is, but some people are more comfortable with adding as opposed to subtracting, because with subtracting, we're looking at subtracting negatives a lot. And so if you wanted to avoid that, You could try to make sure that you always have opposite values with the one that you're eliminating as opposed to the exact same value. So if we multiply everything by -3, that'll give us 9x on plus 3y equals 12 on the top because we haven't changed anything on that. But on the bottom equation, if everything gets multiplied by -3, that's -3 times 2x, which is -6x. -3 times y is -3y equals -3 times 5 is -15. So everything's nice and lined up. And we have opposite values in front of the y's. And so on this one, we're actually going to add together. So if you have opposite values with the variable you're going to eliminate, you will add. And so if you prefer to add every time, just make sure that you end up with opposite values. And so sometimes you multiply by a negative, sometimes you multiply by a positive. If it doesn't matter to you, if you're adding or subtracting, then you could just multiply this by 3 and subtract the two equations. So if we keep working through this, we get 9 plus -6, which is 3. So that's 3x. 3 plus -3 cancels out. So the y's are gone. And then 12 plus -15 is -3. So we have 3x equals -3. And then to solve for x, we're going to divide both sides by 3. And -3 divided by 3 means that x equals -1. And then we'll take our value of x and we'll plug it back into one of our two original equations. So which one are we going to plug it into? First one or second one? Second one. All right. Because we're solving for y, and that might be a little bit easier since the y is by itself here. So we're going to say 2 times x, which would be 2 times -1 plus y equals 5. So I'll put it back into that second original equation. 2 times -1, 2 times x plus y equals 5. 2 times -1 is -2, so that's -2 plus y equals 5. And then to get y by itself, we'll add 2 to both sides, and 5 plus 2 equals 7, so y equals 7. So we have an x equal to -1, and we have y equal to 7, so we're looking at -1, comma 7 for our answer on number 2. So it is a little bit more challenging than what we saw yesterday because we have to make a decision about if we want the variable the same in front of x's or in front of y's. Most of the time it should be a little bit obvious as to what that is. Like on number 3, since this minus y, the y is by itself, we're going to multiply the top equation to match it up with the one down here. However, this time, in order to get opposite values, we don't have to multiply by a negative because this y is already a negative. So the top equation is the one we're going to multiply by. What are we going to multiply the top equation by? What number is this top equation get multiplied by? Yeah, 4. We'll multiply the top equation by 4. Because we're going to end up with opposite values in front of the y variables, which will allow us to just add together the two equations like we did on problem number 2. And so we'll rewrite the top equation with everything multiplied by 4. So 4 times 3x is 12x. 4 times -y is going to be a -4y. And 14 times 4 is going to be, what is that, 56? Yeah, so equals 56. And then the bottom equation stays exactly the same, 5x plus 4y equals 12. So everything's lined up. We've got opposite values in front of the y variables, and when the values are opposites of each other, we're going to add the two equations together. So 12x plus 5x, that's 17x. And then the -4y and the +4y cancel each other out. So there's no more y variable here. And then 56 plus 12 equals 68. So we're looking at 17x equals 68. We'll divide both sides by 17. And 68 divided by 17 is a whole number. It's 4. So x equals 4. To solve for y, we're going to plug back into one of the two original equations over here. So which one should we plug into? First or second? First one. All right. I like first one as well because we're trying to get y, and this y is by itself. So we're going to do 3 times x, which would be 3 times 4, minus y. I'm going to write minus 1y because this will take a couple of steps, equals 14. Three times 4 is 12, so that's 12 minus 1y equals 14. And then subtract 12 from both sides. Negative 1y equals 14 minus 12, which is 2. And then the last thing we need to do to get y by itself is divide both sides by negative 1. 2 divided by negative 1 equals negative 2. So y equals negative 2. X is equal to 4. So our answer, let's write it off to the left here, 4, negative 2. And I just want to reiterate again, if we were to graph these two equations, meaning if we were to get the y's by themselves and graph using slope intercept, these two lines we would graph and they would cross at the point 4, negative 2, just like we saw last week. All right. So that's everything we're going to do from the front page here. So 1, 2, and 3, those are the 3 we're going from the front. Once you've got that down, go ahead and turn to the second page and we will start working through, starting with number 6. Start with number 6 here. All right. So number 6 says 3x plus y equals 2 and 6x plus 2y equals 4. So which equation are we going to multiply? First one or second one? First one. All right. And then what should we multiply by? It could be the positive or the negative version. I see 2. Okay. And then if you wanted to make sure that they're going to cancel out by adding, you would multiply by negative 2. And so I'm going to multiply everything by negative 2 on the top. And if you want to multiply by positive 2, that is totally fine. You will end up with the same answer. So everything on the top gets multiplied by 2, and that's because we've got a 2y down here. We have a regular y here. If we multiply the top one by 2, then that means, or negative 2, that means we either have the same number or opposite number with our y variables because those are going to cancel out. So negative 2 times 3x is negative 6x. Negative 2 times y is minus 2y. And then negative 2 times 2 is negative 4. And then the bottom equation stays the same. 6x plus 2y equals 4. Now we are in a situation where we can set this up here. We have opposite values in front of the variable. So we're going to add together. Does anybody have an answer for this one yet? This one ends up being pretty quick. Because a negative 6x and a positive 6x, those are opposites. If we add them together, those cancel out. A negative 2y and a positive 2y, those are opposites. So those cancel out. So on the left side, we've got 0. On the right side, negative 4 plus 4, those are opposites. Those cancel out. So we get 0 equals 0. We had a question that ended up exactly like this yesterday in our notes. What did we write for our answer? Close. Yeah, this one's infinitely many. Why is it infinitely many instead of no solution? Yeah, these two numbers are equal to each other. As long as those two are equal to each other and there are no more variables, then it's infinitely many. If the numbers were different from each other, then they wouldn't be equal. Then it would be no solution. Yeah. All right. Let's have a look. We'll skip 7. So cross off 7. Let's go to number, see what else is here. Number 8. All right, take a look at number 8. Do you notice any issues in terms of multiplying one of our equations to make this work? What's that? Yeah, both equations have numbers. And if we try to multiply any of these numbers to match the other one, it wouldn't work. Yeah, because if we multiply the top equation by 2, both of the numbers with x and y on the top equation would then be bigger than the ones on the bottom. So if we go back to our very first page here for today's notes, it says multiply one or both equations. So what do you think we have to do on this one? Multiply both equations. Yeah, we have to do more multiplication. Both equations have to be multiplied. This is where I was talking about greatest common, I said greatest common factor. I meant least common multiple. And a least common multiple is what is the smallest number that 2 numbers multiply into. So what I'm going to do is I'm going to print off a multiplication chart and hopefully get these to you tomorrow. But a least common multiple is going to be pretty convenient because if we're trying to find the same number that, let's say, 3 and 4 both multiply into, that's pretty easy to do using a multiplication chart, but I'm sure a lot of you know this anyway. What is the smallest number that 3 and 4 multiply into? So a number that's larger than both 3 and 4 that they both multiply into. Well, yeah. And on a multiplication chart, really all you have to do is match up 3 and 4. So here's 3, here's 4, match them up. 12 is a common multiple of both of them. And it's the least common multiple between the two of them. It doesn't, I say least common multiple, it doesn't actually have to be the least common multiple, but your numbers will be easier to deal with the smaller they are. So let's go ahead and multiply. What do you have to multiply 3 by in order to get to 12? 4. So let's multiply the top equation by 4. And on the bottom equation, what do you have to multiply 4 by to get to 12? 3. And again, I'm going to make sure we have opposite values. So I'm going to multiply the bottom equation by -3. We could have multiplied the top equation by -4 and the bottom one by +3. It doesn't actually make a difference there. But what we're trying to do is we're trying to make sure we have a 12 with the y's. And in order to make that happen, we have to multiply the top one by 4 and the bottom one by 3, or in this case, -3, so we can get opposite values. That way we'll be able to add the 2 equations together as opposed to having to subtract them. So if we head over here, everything on the top equation gets multiplied by 4. So 4 times 3x is 12x. 4 times 3y is 12y. And 4 times 9 is 36. So 12x plus 12y equals 36. And on the bottom equation, we're multiplying here as well. So -3 times 5x is -15x. -3 times 4y is -12y or -12y. And then -3 times 10 is -30. So both equations here had to be multiplied in order to get the same, or in this case, opposite values in front of one of our variables. And because they're opposite values, we're going to add them together. 2 equations get added. And so we're looking at 12x plus -15x, which is a -3x, so -3x. And then +12y, -12y, those are the ones that are going to cancel out. And then 36 plus -30 is 6. So we have -3x equals 6. And if we divide both sides of the equation by -3, we end up with x equal to So this one required a little bit more thinking because we had to realize that I have to multiply both equations on this one in order for us to be able to cancel anything out. All right, let's finish it up. Take your value of x, -2, plug it back into one of the two original equations. So which one? First one or second? First original or second original to solve for y? What do we want to plug in for? The first one? All right, let's do it. So plugging into the first equation, 3 times x would be 3 times -2 plus 3y equals 9. And then we're going to solve for y. 3 times -2 is -6. So that's -6 plus 3y equals 9. We will then add 6 to both sides. So +6 plus 6. And we get 3y equals 9 plus 6, which is 15. Our last step, divide both sides by 3. Divide by 3. 15 divided by 3 means that y equals 5. So we have x equal to -2. We have y equal to 5. So we're looking at -2, 5. And that is our answer for number 8. All right. Cross off number 9. We'll skip that one. And we're going to do the last 3. We'll do 10, we'll do 11, we'll do 12. So moving on here to number 10. What do you notice first about number 10? Anybody notice anything about 10 that's different than everything else that we've seen so far today? Yeah, these two equations are not lined up. They're arranged differently. Yes, we're gonna have to line these up first, then do some multiplication, then be able to solve. So I was mentioning yesterday that standard form is usually the form that you will see most elimination problems in. Everything we've seen today, both equations have been in standard form. X, then y, then the regular number on the other side of the equal sign. Number 10, the second equation is already like that. The first equation, however, is not like that. The first equation has x on one side and then y on the other. So we need to bring our y variable, this 4y, needs to be brought over to the left side. So we're going to change how that first equation looks. So we're going to write 2x equals 4y plus 18. And then we're going to bring over the y variable to the left side so it'll have x and y on the same side, just like the second equation does. That means we have to subtract 4y from both sides first, so minus 4y. And then that'll give us 2x minus 4y equals 18, which is great. That's what we're trying to get. So when we rewrite our two equations, the equations will be lined up. So we adjusted that first equation. So we got 2x minus 4y equals 18. And then the second equation will keep the same for now. So negative 5x minus 6y equals 3. So everything is lined up. X's over x's, y's over y's, numbers over numbers. The issue that we run into now is that we don't have any of the same numbers in front of x or in front of y. So we need to multiply either one equation or both equations to make that happen. And I'll just tell you right now, we have to multiply both equations. And it's up to us which number we want to get the same in front of either one of our variables. So that'll be entirely up to us. And I'm gonna leave that up to you. So do we want to get the numbers in front of x the same, or do we want to get the numbers in front of y the same? Because we're going to have to multiply both equations, and it doesn't really make it more difficult one way or the other. So which one do we want to get the same, x's or y's? X. All right. So we're going to get the numbers in front of x exactly the same. So what number do both 2 and 5 multiply into? 10, yeah. So 2 and 5 both multiply to equal 10. And so the top equation, we will multiply by 5. Because 2 times 5 is 10. Top equation gets multiplied by 5. And because one of these is positive and one of them is negative already, the bottom equation doesn't have to be multiplied by a negative number. It's just going to be multiplied by 2. So top equation multiplies by 5, bottom equation multiplies by 2. And then we're going to rewrite these equations again. So we'll have the same number with x, and it'll be opposite values with x. So 5 times 2x is 10x. 5 times negative 4y is a negative or a minus 20y. And then 5 times 18 is 80. No, it's 90. So it equals 90. 5 times 18 is 90. So 10x minus 20y equals 90 for the top equation. And then the bottom equation, 2 times negative 5x is negative 10x. 2 times negative 6y is a minus 12y. And then 2 times 3 equals 6. Now we've got everything lined up and we have opposite values in front of our x variables. So we can add these two together. Positive 10x plus negative 10x, the x's cancel out. That's what we were going for. Negative 20y plus negative 12y. A negative plus a negative is even more negative, so that's negative 32y. And then 90 plus 6 is 96. So we got negative 32y equals 96. We'll divide both sides by negative 32. And we get a whole number, and it's negative 3. So y equals negative 3. So we have solved now for one of our two variables. Now we have to get x. And I would say plugging in, so just real quick, the easiest one to solve for here, I think would be plugging into the very first original equation, the 2x equals 4y plus 18. And that's because x is already, the x term is already by itself on the left-hand side. So there's less work that needs to be done to solve for x here. So we're going to have 2x equals 4 times y, which would be 4 times negative 3, and then plus 18. We'll do our multiplication over here first. So 2x stays the same. 4 times negative 3 is negative 12, and then plus 18. Negative 12 plus 18 is 6. So 2x equals 6. And then we divide by 2 to get x by itself. And x is equal to 3. So x equals 3. Y equals negative 3. So our answer is 3, negative 3. There we go. Now, that right there is probably the most complicated you will run into, where you have to adjust one equation, first of all, to get them to line up. And then once they're lined up, you end up having to multiply both equations. That is by far the most work you will have to do on any type of problem that we see when you're dealing with elimination. So the last two are also similar to that. Number 11 is a lot like that. 12 is also a lot like that. So let's go ahead and have a look at number 11. So 11, 2x plus 4y equals 6. The top equation, x and y are on the same side, regular numbers on the other. So we're in standard form already, so that's good. And then second equation, 3x equals 12 minus 6y. This is the second one here that we have to make an adjustment to. So we're gonna have to bring over this minus 6y over to the left-hand side. So we're gonna add 6y to both sides, so plus 6y to both sides. We don't have to rewrite it because we're just dealing with that second equation. So we can just write it underneath here. So that'd be 3x plus 6y equals 12. So we move over the 6y. So now we've got the x's and the y's all on the left side, which means we can rewrite the two equations. They'll be nice and lined up. And then we have to figure out what we're going to multiply by. So first equation, 2x plus 4y equals 6. Nothing changes there. Second equation, 3x plus 6y equals 12. All right. Now taking a look here, we can't multiply just one equation to match the numbers, so we do have to multiply both of them. What numbers should we match, x's or y's? It doesn't actually matter, but which one do we want to do? X's? Okay, let's match the x's then. So a 2 and a 3 both multiply to equal what? 6. All right. So the top equation gets multiplied by what? What are we going to multiply the top by? 3. All right. And the bottom equation? 2 or negative 2. Let's go with negative 2 so we have opposite values. You can do positive 2. You just have to subtract all of the equations, but getting opposite values means we can add them together. So the top equation gets multiplied by 3. So 3 times 2x is 6x. 3 times 4y is 12y. And 3 times 6 is 18. On the bottom, negative 2 times 3x is negative 6x. Negative 2 times 6y is negative 12y. Negative 2 times 12 is negative 24. So we got everything lined up. We have opposite values, which means we add the two equations together. And a 6x plus a negative 6x, those cancel out. What happens with the y's? They also get canceled out. All right, so we have 0 then on the left-hand side. And then 18 plus negative 24 is negative 6. This is no solution, yeah. Because 0 doesn't equal negative 6. Our variables are gone. There are no more variables. And so if you end up with two numbers that are different, they don't equal each other, there's no more variables, this is going to be no solution. And so that's our answer for number 11. Again, the no solutions and the infinitely many solutions, those usually take a little bit less time because you don't actually have to solve for any variables because everything cancels out so quickly. All right, the last one, number 12, here we go. 7x plus 5y equals negative 13, and then negative 2x equals 7y plus 26. So first question, do these equations line up? No. All right. Next question, which equation are we going to modify? The first one or the second one? Second one, good. We want to make sure x's and y's are on the left-hand side. They already are on the top equation, so we have to change the second equation. So we have to get rid of the 7y from the right-hand side, so minus 7y from both sides first. And that will give us negative 2x minus 7y equals, that's a plus or a positive 26, so that just equals 26. So negative 2x minus 7y equals 26. That will be our second equation that we write on our next step here. The first equation stays the same, so 7x plus 5y equals negative 13. The second equation will be negative 2x minus 7y equals 26. All right. Now taking a look here, do we have to multiply one equation or both equations? Yeah, it's going to be both because 2 does not multiply into 7 and 5 does not multiply into 7. And because you can't just multiply one of the numbers to make it equal the other one, that means we have to multiply both equations. So looking at the x's and the y's, which of those two do you think would be easier to match, x's or y's? Probably the x. I would agree with that. What number are we going to end up having in front of x? 7 and 2 both multiply into what? 14, exactly. 7 and 2 both multiply into 14. So the top equation multiplies by 2 because 7 times 2 is 14. The bottom equation multiplies by 7 because 7 times 2 is 14. So everything on the top equation gets multiplied by 2. So we're looking at 2 times 7x, that's 14x. 2 times 5y is 10y, so plus 10y. And then 2 times negative 13 is negative 26. On the bottom equation, 7 times negative 2 is negative 14x. So there's our opposite values. That's what we were going for. 7 times negative 7y is going to be a minus or negative 49y. And then 7 times 26. So what is that? 140 plus 40, 182? Yes, 182. Okay. Yes. Couldn't we make it what? We could make the bottom equation positive by multiplying everything by a negative, which means we have to subtract the 2 equations. You're welcome to do that. I'm going to keep it the way it is because when we cancel things out on this one, we're just going to add together all of the terms. And again, if you're interested in using a calculator for this stuff, you are more than welcome to do that. So when we add these together, 14x plus negative 14x, the x's cancel out. 10 plus negative 49 is going to be negative 39. So that's a negative 39y. And then negative 26 plus 182. That's going to be, what is that? 156. So 156. Now, hopefully, this ends up giving us a whole number, and it does. We're going to divide both sides by negative 39. And again, this is something that I would definitely recommend using a calculator for. You could do it by hand, but it would definitely take some time. And that equals negative 4. So y equals negative 4, which is good. Because pretty much everything we've seen ends up being whole number values. So this helps with that. So y equals negative 4. Now, to solve for x, we have to plug back into one of the original equations. Which of these two very original equations do you think would be easier to solve for x with? The first one or the second one? Second one, I agree. Because the x term is by itself, and that's the one we're trying to get by itself. So let's use the second one. So that'll be negative 2x equals 7 times y, so 7 times negative 4, plus 26. Almost out of room over there. So 7 times negative 4 plus 26. All right. That'll be negative 2x on the left still. 7 times negative 4 is negative 28 plus 26. And negative 28 plus 26 is negative 2. So that's negative 2x equals negative 2. Divide by negative 2. And x equals positive 1. X equals 1. Y is equal to negative 4. All right. So definitely more thinking involved in today's trying to figure out what that common number is going to be with your variables when you're solving. We are not going to end up moving on tomorrow to a new section. It's going to be a review on solving systems. We're going to look at all three methods tomorrow. Graphing, substitution, and elimination is the review. Just to see again, I know we did a couple days of review last week.